Section 4.1 Quadratic Function. This quadratic function, quadratic function are very useful function. What happens is we take problem from real life and we try to use some function to model that problem so that we can use our skills or technique to analyze about that function and then finally go back and then conclude our finding for the real life problem. So use of this quadratic function is very useful. I'm going to show you why is that. So in this section we're going to talk about what is quadratic function actually, and then how to plot the graph of quadratic function. And there are three different ways you can do that. We're going to talk about those three different ways. So first of all, quadratic function means whenever your function come with this form, a x square, meaning the power of x is 2 and there is some number in front of x square and there is a b times x plus c. uh, this kind of function is called quadratic function. Make sure that here a, b and c, they might be anything, anything, real number, any real number, except a should be non-zero. The reason, if a is 0, then this term would be would be gone, and then you will have only bx plus c. That means it will be a linear function. So here a, b and c, they could be any real number except a must be either positive or negative. It cannot be equal to 0. Now this function is also called parabola. If you try to plot the graph you will see is parabola. Okay, so based on the value of a, which is the coefficient of x square, which might be positive or negative, you will have two different kind of graphs. So the first one, this is for when a is negative, and then second one, this is for when a is positive. So this first graph is called concave downward, while the second graph is called concave upward. Okay, open down, opens downward, opens upward. Okay, so if you look at this graph, you will be able to see that for the first graph there is a point, this point, which gives you the maximum value of that function, and there is a point here, this one, that gives you the minimum value of that particular function. So if we model real life problem using quadratic function, we will be able to find out either maximum or minimum value of that function. So finding maximum or minimum value, those are very applicable problems in our real life. We always try to find maximum or minimum. For example, maximum profit, minimum cost. We always try to optimize things in our real life. That's why this use of quadratic function, use of this particular section is very useful here uh, to solve the real life problem. Okay, now the question is, how do you find this maximum or minimum value? That's what we're going to discuss later. So the first thing, based on this information, now we know if a is negative, the curve would be concave downward. If a is positive, the curve would be concave upward. So we're going to use that fact here to find out, without any graphing tools, there is a quadratic function. This is quadratic function, and since the value in front of x squared is -3, a is -3, which is negative, so the curve would be look like this. So it opens downward. Okay, that is the answer for this one. Now there are a couple of things you have to understand before we apply this quadratic function to solve actual real life problem. The first thing is we have to know this vertex means either the minimum value, in this case it's a minimum, this is called vertex, and in another case there is a maximum value. So either there is a maximum or a minimum value that occurs at a point, that's called vertex. Vertex means this point, and there is a x coordinate and y coordinate of that point. Okay, so that's a vertex. Axis of symmetry means a line, vertical line, passing through this vertex, which divides this curve into two equal pieces. That's called axis of symmetry. So in this case, in this particular HK point, the axis of symmetry is x equal h. That is the axis of symmetry. Y-intercept, we already know y-intercept means the point where the graph intersects the y-axis. This is the y-intercept. X-intercept means where the graph intersects the x-axis. And then domain, as you know here, the domain is all real number. There is no restriction. But for the range might be, starting from the minimum to infinity, or, in this case, it's a start from negative infinity up to that point, the maximum value. So that depends, the range of this parabola depends on the vertex. Okay, so now we have to find out vertex and axis of symmetry of quadratic function. Sometimes quadratic function may appear in this form, which is called vertex form. Let's say if your quadratic function is in this form, a times x minus h squared plus k, this is also quadratic function, then the vertex of this quadratic function is h comma k. So h is coming from here, so in front of h there should be negative sign. If there is a positive sign, then the h value would be negative, and k comes from this number. Okay, so h comma k gives you the vertex if you have this form of quadratic function, and x equal to h is axis of symmetry. So one example, this is a quadratic function. If you compare this function with a vertex form, with this form I'm talking about, the number in front of this parenthesis here is nothing there, so that means a is 1, and then value of h is 3. Remember, here is a negative sign, here is a negative sign, that's why the h is just a number. And value of k is negative 9. Here is a plus sign, it has to be plus, and that's the only way you can make it plus. K equal negative 9. So we know from a, the curve is concave up, meaning opens up. HK gives you the vertex, so vertex is at 3 and negative 9. 3 and negative 9, this is the vertex. And now we know that graph is look like this, concave up. And then to make the complete graph, you can find out the y-intercept. So y-intercept means the point where graph intersect the y-axis, so that can be found by finding the value of function at 0, which is put x equal to 0 here. That will be negative 3 square negative 9. So that means, what is that? A negative 3 square negative 9, which is 9 minus 9, which is 0. So negative 3 square means 9. So this is the point where the graph will passes through. So that is the one point. And then to find another point, you can also find the x-intercept. X-intercept means a point where the function is, there might be 2 points, function is 0. So that means x minus 3 whole square minus 9 equals 0. X minus 3 whole square equals 9. So x minus 3 is plus 3 and x minus 3 is minus 3 by using the square root property, and that gives us x equals 6 and x equals 0. So x equal to 0 is here, x equal to 6, 1 2 3 4 5 6 is here, so the graph should passes through this point. Okay, so by using a vertex, x-intercept, y-intercept, and because of the a value, we'll be able to plot the graph of graph of quadratic function, which is in vertex form. Now sometime we have quadratic function like this, which is in general form, and we know if we have quadratic function in vertex form, then it's easier to find the vertex. So what we do is we change this general form into the vertex form by using completing square technique. So I'm going to show you how you can do it step by step, and this is the work. First of all, write down your original function, and then after that group this x terms together like here and isolate this constant thing. That's step second. Step 3, factor out the number in front of x square. and that will give you x square minus 2x minus 3. Finally, we have to complete this thing, complete the square of this thing, x square minus 2x. To complete the square of this, we have to add something, and here you see that we have to add the number which comes after you divide this number by 2, square of that number. So if you divide 2 by 2, that will be 1, so you have to add 1 square. So that's why I'm adding 1 square. 1 square means 1, but because there is a 2 outside the parenthesis, that means actually I'm adding 2. So I cannot just add any number in the function. So to make balance, I also have to subtract the very same number. So this technique is called complete the square. So I can add 2 and then subtract 2. By doing that, what I can do is, you can see that I am just copying this 2, and instead of x square minus 2x plus 1, I can write down this as x minus 1 whole square. And then for rest of this constant, this is just negative 5. So this is the vertex form of a quadratic function. So by looking this vertex form, we can find out the vertex, which is 1 comma 5 negative 5, and then we can find out the x-intercept, y-intercept, and because a is positive 2, the curve is concave up. So we know everything about that quadratic function if we can change this general form into the vertex form. And this is the process, this is the steps, these are the steps you can follow, which is mainly completing the square, to change the quadratic function in general form to the vertex form. Okay, sometime you don't want to do that, you don't want to change the general form into the vertex form. In that case, there is a vertex formula to find out the vertex of parabola, and here I'm going to give you the formula. If you have a function ax squared plus bx plus c, then you can find out the vertex by using this formula, where the x coordinate of vertex can be found by negative b over 2a, and then y coordinate of the vertex can be found by finding the value of the function at this point. So this is the vertex, that's the formula you have to know if you want to use this formula. And the axis of symmetry is x equal negative b over 2a. I'm going to do one example here. In this case, the function has ax squared plus bx plus c. We can compare this to function and we can find out a equal the number which is in front of x squared, b is the number in front of x which is negative 6, and c is nothing here, that means 0. So now we can use this formula for finding the vertex. So x equal negative b over 2a, which is negative, b itself is negative 6, 2 times a is 1, so it's a 6 over 2, which is 3. And y coordinate of the vertex is the value of the function at negative b over 2a, which is the value of the function at 3. So plug x equal to 3 here, so that will be 9 minus 18, which is negative 9. So 3 comma negative vertex is 3 comma negative 9, which is basically I'm taking the same function actually, we already use it here. So it has the vertex negative 3 comma negative 9. I was using the very same function but in the different form. So by using this vertex formula, we can find out the vertex, we can find out the x-intercept, which is 0 and 6, because this is the same as, this function is actually same as x minus 3 whole square plus, sorry, minus 9. Okay, this is same as this one, which is we already did that, we already used that function, so we already know what are the x-intercept, what is the y-intercept, and then vertex. So we'll be able to use that information one more time, and then we can just plot the graph. Okay, so if you have general form, then we can use the quadratic the formula for finding the vertex. If your quadratic function is in this form, this is the formula for finding the vertex and axis of symmetry. Okay.